This is George Sakalis and this is Sprint 5. Okay, so here's my terrain, here's my tank. So it hugs the features of the terrain. I'm displaying the cells that I'm colliding with, and the cells colliding with the actual volume. So there's that. Also, I have working well, my turret now rotates both on my x-axis and my y-axis, and I've been playing around with some bullet drop effects. Okay, so that's the demo. I'll start with my terrain class. So it creates a terrain. Get my buffer for my y values from the height map. I create my array of vertices, create my triangle winding. This is also in my triangle winding. That's where I also set the min and the max for each given cell. So this is build vertices. So it's pretty much the same thing as last quarter. Get my position, get my UVs, create my normals, given my using my 6 surrounding faces for my given point, and then just pass that into my list of vertices. One triangle, nothing really different except I'm also calculating my min and my max for each given cell. Intersect, so this tests the intersect between my ship and my terrain, each cell in the terrain. So I form a AABB around the B sphere. Well, I don't form an AABB, but I get my min and my max from my B sphere and its radii, which forms that box. Using these 2 points, I can then get the range of cells that I need to test. And then, yeah, and then I just test to see if those given points intersect with my current, whatchamacallit, my current collision volume on the ship. Um, and then for orienting the ship with the terrain, so what I'm doing right there is I'm putting my ship's position inside grid space. If I then subtract my indices from my exact position in grid space, that'll give me my barycentric points, my x and my z, my beta and my gamma. I can then plug those into the functions for the given norms and that stuff, and that will actually give me the norm. And then I just pass that back to the ship. The ship then uses that it's up. It then calculates its forward using its up and its left, getting the cross product of the two, and then it computes its new left using its up and its forward. And then I just reconstruct a rotation matrix from that. So yeah, bullet drop. Nothing too crazy. All I'm doing is I have a float for my acceleration. I just add that every time to my drop speed, which gives me that nice arc. So yeah, that's bullet drop. That's everything. That's my stuff for my demo and my game and my terrain stuff for my graphics stuff. So this week I focused on getting my getting support for my inputable system and my alarmable system. So in my graphics side, I just I kept the same naming conventions, just to make things combining things a lot easier. I just have an enum for the Azul keys, and then I just have get key state, where I pass in the Azul key, and that'll give me the state of the given key. For time stuff, all I really needed to do was get the the system time, and then pass that to the time manager. Where is here? Okay, yeah. So just get time in seconds, and then that just grabs time from the timer, and then my time manager uses that. I was running into some problems with getting a freeze frame to work, but I'm gonna revisit that at a later time. So if I press space, it will go through my inputable system and create a bullet, and then my bullet will it has an alarm on it. After a given amount of time, it will delete itself using the alarm. Okay, yeah. And yeah, that's everything I did this week. Next week, I'm gonna work on getting the train stuff to work with my DX stuff. And then after that, the only system I'll need to really implement into my DX side will be drawable. And yeah, that's it. Okay, that's it.